very good morning, good afternoon and good evening to all my dear friends, students and participants. Welcome to this NPTEL MOOC course, title of which is Application of Forecasting, Regression and Time Series Model. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as all of you are aware, which I keep repeating for each lecture. So, this whole MOOC NPTEL course consists of three broad parts. Number one is in the area of forecasting and different techniques. Number two is in the area of regression models, even though it is written multiple linear regression, but it is regression models. And the third part is time series analysis. Now, today, which is the last class, will cover the part of regression models, and with this we will end the second part and then start the time series analysis. So, week number 10 and this is lecture number 50. So, as you are all aware, this whole course consists of 60 lectures for 30 hours and each lecture is being from half an hour. And as you are all aware that each week we have 5 lectures, each of half an hour, and after each week we have assignments. So, with this technically the 10th week people after this would be appearing for the assignment number 10. So, what is the coverage? Now, to give a background that in regression models, because this is the last course, I will just give a brief preview of whatever we have covered. So, we have covered the concept of multiple linear regression, where y is the dependent variable and x 1 to x k are the independent variables, and there were different assumptions about normality, heteroscedasticity, autocorrelation, non-autocorrelation, homoscedasticity, all these things. And we had considered that in multiple linear regression, the main idea was to basically make the error as minimal as possible. Error, as you know, is the difference between the actual value of y and the predicted value of y. We found out the square of the errors, added the errors and minimized that. Now, what is the advantage of this concept? And again repeating it, sorry, because these concepts are very important. Minimizing the sum of the square of the errors is akin or exactly equal to trying to minimize the variance. And trying to minimize the variance, you will find out the best fit values or the estimated values of beta. And if we remember, we have covered the ideas that what is the expected value of the beta in the long run, or what is the unbiased estimates of the beta, and we also found out what was basically the variance of the beta hats, unbiased estimate of beta hats and variance of beta hats, and we also found out that what is the best estimate for sigma square, because sigma square was basically the variance. And if you remember, we have considered the error to have a certain expected value and a variance, and we considered the expected value as 0. Then later on we went into the part of trying to consider that what if we consider the balanced loss function, where you are trying to balance it. Balance considering that there is a precision of estimation and there is a goodness of fit. Precision estimation is related to trying to find out the betas, and goodness of fit is related to finding out how good the fit is of y hat with respect to y. Y hat is the estimated value or the predicted values. Then we considered different combinations of loss functions. So, generally the loss functions were that you had the linear loss function, then you have the 0 1 loss function, then you have the exponential linear exponential loss function, Linux loss function, and we considered that combination of loss function in the balanced loss function as either it is squared error, SEL, or the Linux. And during using these corresponding facts, we found out what was the estimate of beta hat or as required for theta hat. Theta hat was basically a linear function of betas. Betas are the regression coefficient. And then for different combination, whether you are putting 100% weightage to estimation or 100% weightage to the goodness of it, we found out a whole set of simulated runs and gave the idea that how you can plot, and we did different type of plots of and also showed the graphs and showed the values also how the balance loss function can be found out for different combinations of Linux loss and squared error loss. Then if you remember, we went into the concept of logit models. Logit models and the one which you are going to do is the Probit, and that is why this whole introduction I am giving. The logit models and Probit models are similar to each other, and we will see that later on. And now, after the logit models or logit regression models, we went into different ideas of nonlinear regression, and in nonlinear regression, if you remember, rather than going to the theory, I considered different type of nonlinear regression models, and considering the nonlinear regression models, and all of them were solved or simulated in Excel sheet, which I had shown, with an idea that considering different values of, say for example, the error distribution. So, if you remember the error distribution, the main idea was to keep the error expected value as 0, and based on that you simulated. So, you can either have a uniform distribution between minus a to plus a, or you can have the standard normal distribution, or you can have the t distribution, provided n is large. So, that the t distribution becomes exactly equal to the standard normal distribution, because the expected value of the t distribution and the standard normal distribution is 0, number 1, and number 2, as n, which is the degrees of freedom for t distribution, increases, the variance of the t distribution becomes exactly equal to 1, which is for the standard normal distribution also. Now, in the nonlinear regression models, we considered different ways of trying to simulate what was the error, and based on that we found out the best fit line, and also we simulated the data considering different errors, the generated data which you will have, or as akin to the actual data for the different type of nonlinear regression model. There were 9 to 10 different nonlinear regression model, and we showed that is you change the parameters, which was theta 1, theta 2, theta 3 in one case, and another case was exponential alpha also. We found out different combinations of each of these 9 models, at least 4 combination for each. That means 9 into 4, which was 36 different type of models considering different type of nonlinear regression data. Now, today we will basically go for the Probit regression model. So, again I am repeating all this background was basically to sum up that what we have discussed in the ideas of regression models. So, we will discuss the brief idea of Probit regression models and with examples. Now, if you remember in the logit regression model and the Probit regression model, the idea is that your variable y, which is the dependent variable, can only take binary results. That means, either answer is yes or no, 0 and 1, or black and white, or success and failure in this way. Now, the idea is that if we want to find out the values, we also want to find out that what is the corresponding probability for that. So, that is why the Probit models would give you the probability of the y value taking a certain value depending on the x values which you have. Now, here is how the idea works, and based on that we will try to simulate and check. So, the idea is like this. So, in the Probit model, regression model, or in the logit regression model, or in the case of multiple linear regression models, the idea is that you want to find out y I as it is given, based on the fact there are k number of independent regressors, and the regression coefficients are given. There is a constant beta naught as usual as we had considered there, and the other regression coefficient corresponding to x 1 to x k are denoted by beta 1 to beta k. And obviously, the idea remains that we need to find out that what is the best value of beta, such that your Probit model or the logit model or the multiple linear regression model gives you the best result. Best result based on the fact that you are able to predict, and also you want to basically minimize the error, as we have been discussing time and again. Now, in general, as is mentioned, y I means the reading number is equal to beta naught plus beta 1 into x 1. X 1 is the first regressor independent variable. I again is corresponding to the reading number, and the last regressor is beta x k multiplied by beta k, which is the regression coefficient with respect to x k, plus there is an error and which I am denoting by epsilon 1. Now, if y, now in the case when you have the binary output, it is mentioned here, as you can see in the second bullet point, it is given that your y 1 I can be 1 if y I star is greater than a particular threshold value, and y I is equal to 0 if y I star is less than the threshold value. Now, the reason is that as you want the answer to be binary, obviously you need to find out based on the answer that what is the corresponding probability that the values of y would be as assumed, and this is what the discussion would be. Now, what is important in this case is that considering that we would not be able to draw the multidimensional case, we will take the case where you have only one regression model problem, and we will try to delineate it with both a graph as well as in the equation. So, the main idea is that I want to find out, or we want to find out the expected value of y given x is equal to x. These x's are basically, remember, they are bold in the sense they are the corresponding vectors. So, expected value of y is to be found out, and we want to find out that the case that what is the probability that y will either take the value of 1 or you will take the value of 0 depending on the outcome of regression values, which is basically x bold. X bold means the independent variables, and our answer has to match in such a way that we are as close as possible to the theoretical result with respect to the practical result which we are getting. So, in case we have one regressor, as I mentioned, we will consider this as the problem. What the problem is that given some value of beta naught and beta 1, based on the fact that x 1 takes a realized value x 1 star, we want to find out what is the corresponding probability of y taking the value of 0 or 1, or taking the value of binary two values, which we have already mentioned. It can be the success or failure, it can be the 0 and 1, it can be the right or wrong, whatever the case may be. But we are only going to take 0 and 1 for our case for better understanding of the problem. Now, the idea is, if you remember, that the Probit model, regression model, is given as highlighted in this yellow color. So, y is equal to beta naught plus beta 1 into x 1 plus epsilon. So, beta naught again is the coordinate where the y axis is touched by this linear line, and obviously, in that case x values are 0, and we are considering for the time being this is the best fit line such that the error term would not be coming into the calculation. Now, if error term was there, obviously, the points would have been like this. We will see that later. So, this is basically the best fit based on which we are taking, number 1. And number 2 point is, so if we have, so this point would basically be the beta naught. Now, the problem is this. So, if I am considering any value of y is 0 and 1, what if the value of y is between a certain value? So, I am considering the values of y can be either discrete, in the sense there is they are exact equal to 0 and 1. What if they are not, and how do you replace it? Now, remember one thing, in this Probit regression model or in the logit regression model, the idea is basically to find out the probability, that is number 1. Now, if we consider the probability distribution function for any distribution, whether you have the discrete case or the continuous case, you have either the PMF, which is probability mass function, or the PDF, which is the probability distribution function. Till now things are as it is, but obviously, in the discrete case and the continuous case, the PMF or the PDF are of different forms depending on the parameters, scale, shape and location parameter which you have. And obviously, in the discrete case, in many of the cases, like in the Poisson distribution, if it is discrete, the values of x are from 0 to infinity, all integers. In the case of exponential distribution, it is 0 to infinity, but all continuous, provided a, which is in the exponential distribution, if a is 0, the exponential cases are from 0 to infinity. If I consider the case of, say for example, in a normal distribution, the x values are from minus infinity to plus infinity. If I consider the chi-square distribution, the values are basically from 0 to infinity. Now, how do we solve it such that we ensure the probability concept is well taken care in this case? Now, remember, for any distribution, discrete or continuous, the CDF value or the CDF function which you have, which is denoted by capital F, which is the distribution function, has some unique properties which are applicable for all the distribution, whether discrete or continuous. So, we will discuss that, and I will basically verbally state that, so that it will become clear to you, and also write it as applicable. Now, remember the CDF value, which is basically the addition of the probabilities. So, the probability values cannot be neither be less than 0 or cannot be more than 1. So, obviously, the sum of the CDF values would be between 0 to 1 in all the cases. That is point 1. Point number 2 is that as the probabilities cannot decrease, so the probabilities would, if you keep adding up the CDF values, it will be in the increasing function. So, increasing function in the sense that if I have, so let me, so the first case would be I use the color violet. So, in the first case, if you have, say for example, x 1 is less than equal to x 2, these are the realized value. So, in that case, f of x 1 is less than equal to f of x 2 always. That is point number 1. Point number 2 is that the case for f of x and in the limiting case as x tends to minus infinity, the distribution function value basically is 0, because you are adding up all the CDF values which are from minus infinity to minus infinity. That means, the total area covered is 0, hence it is 0. In the case, the third point is, as x tends to plus infinity, f of x tends to 1. This is the third important property, which means the sum of all the properties as you add up all the realized values corresponding properties, that should definitely be equal to 1. So, these are the 3 important properties. Another important property for the discrete case is that because it is happens in jumps like a step function, hence in that case the distribution function is right continuous, nothing to do with the left continuous. So, its continuity is basically from the right, but for the case for the continuous distribution, because all the values are applicable. So, the concept of right continuous, left continuous would not matter. So, again I am repeating, out of these 4 points, number 1 is limiting case of x tending to minus infinity, capital F of x is 0. Number 2 is that, so I will mark it as the first one. The second one is limit x tending to plus infinity, f of x is equal to 1, and third one is that x 1 less than equal to x 2, capital F of x 1 is less than equal to x 2. So, with these 3 notions, we will try to basically formulate the Probit regression models. Now, for a model where we have the probability of y is equal to 1 for any value x is given as a linear function. So, what is the advantage and disadvantage? Of course, there are some advantages. It is very simple to estimate, either 0 and 1, and you find out the answer, and is easy to interpret. So, it is either yes or no, 0 and 1, success, failure, and we do it like the binomial distribution outcome. Inference is the same as you do for the multiple linear regression needed, considering the concept of heteroscedasticity and all this concept of the errors, which you have already discussed in quite details in the regression multiple linear regression model. But what is the disadvantage? Linearity may not be true for many of the practical examples. Linear relationship between the regressor, the x's, and with respect to the independent variable y, which can take binary values. Number 2 is, which is much more plausible and which makes sense, is that The predicted values can be, say for example, when you are trying to find out predicted values in the sense that based on this values of x you get some value of y. What if the corresponding probabilities are between 0 and 1? How would you rank it? Because y is 1 with probability 1, y is 0 with probability 0, or vice versa depending on the case it is. So, what you need to do is that basically replace the linear relationship between the distribution concept, not the linear relationship which is given in the equation y is equal to beta naught plus beta 1 into x 1 plus epsilon, not that, but we want to replace the corresponding probability linear relationship with the S curve. And what is the S curve? We will come to that later, and that if you remember I had mentioned time and again when we are discussing the CDF value of the capital F value of the distribution function. Thus, for these linear models as we have for considering the x value is only there is only one x value, the linear best fit line would be beta naught plus beta 1 into x 1. Now, obviously, there is an error. Two important notions should be met, which is that you can have the probability of y is equal to 1, because there are two outcomes which for which the probability is between 0 and 1 for any value of x. It is possible, that is likely, or and also that as the values of x changes, if it is an increasing function, in that case the probabilities of y increasing for as y increases would also keep increasing till the maximum value of 1, which we are considering as the probability, considering the case that we have under our consideration and the model as capital F, for which as I mentioned few minutes back we will replace with the S curve. And what is the S curve? That is what we will discuss now. Now, for any CDF value function, if you remember, we have considered that the, say for example, I am considering the value of standard normal deviate. So, if I draw the standard normal deviate, I am just drawing it here and then I will erase it and come to the x curve. So, if I consider the standard normal deviate, this is the value of 0, the standard normal PDF function looks like this, which is the z is distributed of n 0 1. N means normal, 0 is the mean, 1 is the standard deviation. Now, if I replace this corresponding PDF with its CDF function, so I will draw it here with the red line ink. So, this would be the CDF function, and the maximum value for the red line is basically 1, because the CDF value can be 1. Now, this type of property for the CDF function is true for all the distributions. There cannot be any change, because it is a monotonic increasing function, not strictly monotonic, monotonically increasing function, and the values which you will have when plotted would give you the curve which looks like an S, whether it is flatter S or it is more upright S will depend on what is the type of PDF or the PMF which you have, and depending on the PDF and the PMF you can basically plot the distribution function which will come. Now, the blue line which you see, the blue line I will use the blue line which you see, so what is the important part? It starts basically the y value, the probability value. I am just drawing the S curve, but I will basically make it clear what is the actual axis y and what is the actual axis x. Y values basically start from 0, which I am putting a tick mark, and goes to maximum 1, because that is the CDF value maximum value. And the x value is basically the random variable which starts technically from minus infinity and goes to plus infinity. So, it will go to plus infinity on the right hand side and it will go to minus infinity on the left hand side. Now, what is the advantage? The advantage is for a corresponding value of x, if it is 4, then the corresponding y value would give you the CDF probability, based on that you can utilize to fit in the Probit model, as we will see later on within few minutes. Now, that will give the chance that based on the value of y which you found out from x, we will be able to say that what is the probability for y taking that value. So, if probability is 1, which means that with certainty we can say that for a certain values of x, the value of y taking whatever it is probability is 1, and in other case if it is 0, which means the probability is 0, and any in between value is also allowed depending on the value of x which you have already seen. Now, if in case x is plus infinity, then the corresponding probability is plus 1. In case if it is x is minus infinity, the probability of y is minus 1. Now, why I am saying plus infinity and minus infinity? Because if you check the equation, what you had was beta naught plus beta 1 into x 1. X 1 can take any values which I just mentioned, beta naught beta 1 can be any value. So, depending on that, the overall value for this green equation which I have written can be from minus infinity to plus infinity. Now, the question which will come out immediately, can we map that to corresponding probability? Answer is yes. How? Because the normal distribution, if you remember, the x values are from minus infinity to plus infinity, and the corresponding CDF values are always between 0 and 1. So, we use the concept of, say for example, one example being the standard normal distribution will be used corresponding to the x values, you will have the probabilities and use this concept to basically find out the values in the Probit regression model. Now, for the logit model, distribution of the errors is given by this. We will plot it for the Probit model, considering the standard normal and the standard logistic distributions would be there to give us an idea. So, given the error is distributed like this, I will just highlight. I am not going to the theory, but I will plot it. Given that the standard logistic distribution would have the errors, and for the Probit model, distribution of errors being standard normal, which I am again highlighting, we will see how the distribution would look like. So, these are the assumptions we are taking, and based on that we are proceeding. Now, this is the graph. Remember, this is the graph for the PDF, not about the CDF. So, if we look at it, the 0 value is the median, mean or mode value. For the standard normal, which I am marking in green and the curve is shown in blue, and the one which you have the standard logistic distribution values, which I am marking in, say for example, red, is this one which is shown in orange. Very interestingly, both the mean values, median values are 0 in both the cases, number 1. Only difference is in the standard normal distribution and the logistic distribution, the standard normal is much more packed up. So, the spread for the standard logistic distribution is much smoother and happens in such a way that you can, the overall area is 1, but you proceed step by step much slowly in order to incorporate that in one of the models, as already mentioned in the last slide, based on the logit model on the Probit model. Now, if you remember, I mentioned something about the PDFs. Now, what if we have the CDF value, which is basically the S function which we are discussing. So, this is the CDF of the standard normal and logistic distribution, considering the S function or the CDF values. The standard normal distribution is given by the blue one, which I will mark in violet now, and the standard logistic distribution is basically the orange one, which I will mark in the red point. Remember, very interestingly, the value of the middle, which is the mean median, is still 0. In one it is spread out slowly, and another is basically concentrated, concentrated being for the normal distribution. Now, let us go through the simple problem. I will just solve a problem, and it will find, you will find out it will be true for all the cases. Consider I need to find out the standard normal deviate. So, this is capital phi, if you remember, this is corresponding to the standard normal deviate for the CDF value, and there is some arbitrary value beta naught and beta 1 x, and if I plot it considering some value, I take beta naught as -3, beta 1 as 2 and x as 1, and the corresponding standard normal deviate which you want to find out for probability of y is equal to 1 is given as capital of -1. Now, what is that? And this is what we will show it in a simple standard normal deviate table. This is the standard normal deviate table. Now, this we all have, we know, we have encountered. So, in the left panel you have the standard normal distribution graph drawn. This is the PDF value, we need that only. And in the table which you have basically the standard normal probabilities. In the leftmost column we have the z values, the topmost row you have the second decimal of z values, and the inside values are the corresponding CDF values. Say for example, as shown here in this diagram, for a value of 1.56 the total area is given as 0.4406, and this is the hashed pink area. Now, the question will come up that what happens to -1 as we encountered in the last slide. So, -1 if we see, I will use a different color. So, this is +1, the value is 0.3413. Now, this is on the right hand side. If I check -1 onto the left hand side, so and it is symmetric if we remember. So, the symmetric value would mean that the area onto the right hand side, left hand side of 0 till -1 is 0.413. And obviously, if the total area if I consider, it is 0.5 onto the left of 0, which is the mean value, and also 0.5 to the right of 0. So, if you consider that, you can utilize this to calculate the values accordingly. So, because all the values of beta naught plus beta 1 into x would always be between -infinity plus infinity, and you can basically map it to find out the standard normal deviate from the table. Now, without going into the coding, I have just utilized this graph. So, this is the Probit regression model. The blue points which you see are the observed values, and the fitted line is given by the red one, and if you see, this is the Probit curve is exactly equal to the S curve. Now, what is the advantage? The advantage is that if I consider, say for example, let me consider this line. So, value of predictor being equal to about between 3000. So, if I consider 3010, so about this value which is 3105 or 3150. Let me consider this 3150. 3150. I have the corresponding probability from here, and if you see in the success rate is given, the probability is between CDF is 0 to 1, and based on that I can find out the errors, which is the difference between the red line and the blue line, and I can plot it. So, once you have the data, you can plot the S curve and find out the corresponding probabilities and the values of the best fit line and the errors, and you can basically do a simulation to find out how the answer would be. This is the same exact type of simulation which we have done for the nonlinear regression part. With this, I will end this linear regression part or regression model part, and from the next class we will start about the concept of the time series model. Thank you very much and have a nice day.